Now imagine that we've collected 2 buffers of such PCM data. These buffers contained in pdata1 and pdata2. What we have here is a simple technique of how we can sum this data together. ptemp_buff will be the buffer that will combine the data of pdata1 and pdata2. Temp_buff is, as a minimum, is twice the size of the data contained in data 1 and data 2. Using this simple technique, we can combine the data of pdata1 and pdata2 into ptemp. This is the resulting combined data which we can play. It might be necessary to scan the resulting combined buffer and perform any clipping as necessary. This code extract simply loops round the entire contents and checks each value to see if it's greater or less than the maximum value or minimum value that an entry of that type can contain. Having done that, we can simply feed this resulting buffer to the right buffer of the audio out instance. So this is the combined buffer which we can play. So it's a simple technique. You may wish to achieve this in a different mechanism, but this is simply a suggestion of how this can be achieved. So now I'm going to move on to image and video management and show how the bada platform can encode and decode various image types and video types. Firstly, with images, it's possible that we can encode and decode and convert images. The bitmap pixel formats that we support are listed there, and we can decode BMP, GIF, PNG, all the common types, and we can encode into BMP, JPEG, and PNG. When making use of image classes, you're required to make use of the image privilege. So let's have a look at an example how we can decode and encode images. What we have here is a method, load bitmap, and the object of this method is to return a pointer to a bitmap from an image. So what we can do, we can create an image instance, and then we can construct using two-phase construction. With the image instance, we can call the decoding method, and what we can do is we can pass the name of the file that we wish to decode, and we can also specify the format in which we wish to decode it into. Again, note it's an end-postfix method, so what this will return to us is a newly allocated instance containing a pointer to the bitmap. We can then return that bitmap, use it as we see fit, but the calling function has ownership of the returned memory as a result of calling an end-postfix method. If we have a bitmap, we can encode it to a file. We simply call the encode-to-file method on the image instance, and we specify the image format. We can specify the name of the file, and we can also specify that if the file currently exists, it will be overwritten. Let's have a look at video playing. We can play back video in 2 ways. We can make use of the player class, or we can make use of an overlay panel. More on overlay panels will follow shortly. If we're going to make use of the player class, we create a player instance. Two-phase construction, we pass the pointer to the event listener, and we also pass a pointer to the buffer info. The buffer info is a buffer which will be used to render the video. What we can do, we can pass the path of the file to be opened to the open file method, and then we can simply call play. The video will begin playback. Again, common operations, pause, stop, and close are available. Overlay panels. Overlay panels are primarily used for the playback of camera previews, but they can also be used for playing back video. Now, the construction of an overlay panel is that it consists of a background buffer and a foreground panel. The background buffer being where the video is actually rendered. Think of the foreground panel as like a transparent film over that of the background buffer, onto which you can superimpose overlay graphics and controls. Right, so this is how we can use an overlay panel. Here we see the creation of an overlay panel instance, and we construct with a rectangle object which defines the size, the viewport of the panel. We can then add control of that panel to a form. The panel itself is a control to which we add it to a container, the form. On the panel, we can call the get background buffer info, and this will populate the buffer with the necessary information to be rendered. Again, here we can simply see how we can construct a player instance containing the pointer to the event listener and the buffer info which we've obtained. Okay, let's move on to streaming now. We can stream both audio and video content. The streaming protocol that we support is RTSP, and we have support for the following codecs: MPEG-4, H.263, and H.264. For audio streaming, we can support the following codecs: AAC and so forth. Again, using a player instance, it's very simple to invoke streaming. We have the open URL method to which we can pass the URL to the content that you wish to stream. Okay, so what I'm going to do now is show you a quite trivial video showing how we can very simply embed video into your applications. Okay, so what we're going to do is run the video player. So this is obviously the video which you saw during the start and just after the first break. But what it does, or what it illustrates, is the ability of how simple it is to embed video into your applications. Okay, so let's return back to the presentation. Right, some tips for you as developers, what things you should consider when making use of audio and video in your applications. When working with PCM, we suggest that you make use of the following parameters. So stereo sound, using a sample rate of 41.1 kilohertz, and using 16 bits per sample. It's our recommendation. Again, we also suggest that you make use of the double buffering technique to reduce latency and ensure seamless playback of audio and video. And if you believe it to be necessary, make use of various sound mixing techniques to enhance the sound of your application and best use the available resources and processing on the platform.